Okay, welcome to your fourth lesson of organic chemistry. We're looking at alkenes today. So far, you have looked at a range of organic chemistry. You've looked at crude oil. You've looked at how we separate crude oil into its fractions by a fractional distillation. You've looked at alkanes in detail, their formula, how to draw them, how to name them. And you've looked at combustion, so that's complete and incomplete combustion of alkanes. Okay, so today we're going to be focusing on alkenes. This is what AQA expects you to be able to know, remember, and apply to questions. So we'll be going over all of this today. So alkenes having a double bond, that means that they are unsaturated. They've got a formula, just like alkenes, a general formula that we can use to work out how many carbons and hydrogens they have. You need to be able to name them, and you need to be able to represent them in their formula version and their structural displayed version. You also need to know the test for alkenes and the colour change that occurs with that. Okay? So a little bit of a recap on alkanes, first of all. We know there is a single bond between all of those carbons. We know that there is no extra space where we can fit any more hydrogens around those carbons. That means they're fully saturated. We remember the formula CnH2n plus 2, which helps us work out how many hydrogens there are for every carbon atom. So if we have 2 carbons, for example, we need to double it and add 2. So if we had C2, we would have H6. All our alkane names ended in ane, so they were alkanes. And the vast majority of our alkanes were used as fuels, so we burnt or combusted them. Okay, they were oxidized. So alkenes are slightly different, and you need to be able to tell the difference between alkanes and alkenes. So alkenes contain a double bond between a pair of carbons. Okay, now at GCSE, you are only expected to know that that double bond is on the terminal of your chain of carbons, which means it's on the end of the carbons. So it's either between the first and the second, or the last and the previous carbon, okay, in your chain when you're writing it out. We know that they're unsaturated with hydrogens, so you'll be able to see later on when we're drawing them that there is space for other atoms to fit. Okay, they don't because we've got a double bond in there. Alkenes have the general formula CnH2n. So that means however many carbons we have, let's say 2 for example, we have C2. The formula for an alkene with C2 would be C2H4. We've doubled it, okay? All our alkenes end with ene or ene, and we tend to use alkenes for making plastics or polymers and other useful chemicals like pharmaceuticals, which are drugs that you take, okay? So, naming our alkenes, okay? Pause the video, see if you can remember the prefixes that we used for alkanes. Okay, our prefixes with alkanes, so 1 carbon chain length was meth or meth, then we had eth, we had prop, we had bute, we had pent, and then we had hex. Okay, now see if you can name the alkenes. Now, methene is not possible. Do you know why? Alkenes need a double bond, which means that they need 2 carbons to start with. So there can't be an alkene with only 1 carbon, which is why methene doesn't exist. Okay, pause the video, see if you can name the first 5 alkenes. So that's ones with 2, 3, 4, 5 and 6 carbons in their chain length. Okay, just like with alkanes, we add an ending, a suffix, onto our prefix, which is ene. Okay, so we should have ethene, propene, butene, pentene, and hexene. Okay? Can you work out the formula of those alkenes? The general formula is at the top of the formula column if you need a hint. Pause the video, make sure you've done that. If you haven't, do it now. Okay, so ethene, we should have C2H4, propene C3H6, butene C4H8, pentene C5H10, and finally hexene C6H12. Okay, notice the H's are always double the C's. They could ask you this type of exam question. So we've got a structural displayed formula of ethene and it's asking you the correct formula for that. They've given you 3 options, it's a tick box, 1 mark. You can do this a number of ways. You can remember what an alkene is and the general formula, so double the amount of H's than C's. You can remember the structure of ethene, ethene being something with 2 carbons in, or you can look at the picture, count the amount of carbons and hydrogens and write them out. Okay, we should have worked out the answer is C2H4. They could ask you something like this without giving you a drawing. A little bit harder. So this is more a standard or a high demand question, so something at the end of the foundation paper or the start of the higher paper. So it's asking for the formula of pentene after it's told you that it's got 5 carbon atoms in it. So you should be able to fill in C5 easily. And then remembering alkenes, the general formula, should fill in C5H10. Okay, worth a mark. That mark might be the difference between a grade. So it's really important you have a go at these. So we need to be able to draw our alkenes, and these are a little bit more difficult than our alkanes. So we're going to have a go at drawing a alkene with 4 carbon atoms in it. Quick check, can you remember what it's called? Using that mnemonic, monsters eat pupils but prefer hamburgers. If we look at the 4th word, but, okay, that's our start of our alkene, so we're going to draw butene, okay? So the first thing we need to do is draw out 4 carbons in a row or a chain. That's the simple part, okay? We know normally if we were drawing an alkane, we'd put a single bond between each of those carbons in a chain. We're drawing an alkene though, which means we need to draw a double bond in there. We could put it on the left-hand side, or we could put it on the right-hand side. It does not matter, okay? I would pick a side and go with it. There are in the universe, those with a double bond in the middle. However, you are not expected to know that at GCSE, only at A level and degree level. Okay? So our first step, we drew our carbons. Second step, we joined them up with a line. That represents our covalent bond. Our third step, we put one double bond in there. Our fourth step, we're going to need to add some hydrogens. Okay, so we'll start at the left-hand side. This carbon has got one bond coming out of it. We know carbon wants 4. It's in group 4. So we draw 3 hydrogens around that carbon. Moving on to this carbon, it's got one bond coming out the left and one out the right. So we need to draw 2 hydrogens on. This carbon has got one bond out the left and 2 out the right-hand side. So that's 3 bonds. So it only needs 1 hydrogen. You could draw that at the top or at the bottom, doesn't matter, as long as there's only 1. Then our carbon on the right-hand side, we have 2 bonds coming out of it, so we just draw 2 hydrogens there. Okay, they can be facing up, down. You could have one at a right angle rather than opposite each other. It doesn't matter how you draw them, or if you draw them at slightly bent angles, that's fine as well. Okay, so one of our animations didn't work. You've got the structural displayed formula for butene there. Okay, so something with 4 carbon atoms, that's what we've just drawn. It is exactly the same as what we've just drawn, but it is the opposite version. So if you drew your double bond on the left hand side, so you can see that there, it's just the opposite version. Okay, I'd like you to pause the video and see if you can draw the structural displayed formula for ethene, propene, pentene and hexene. Okay, have a look back. How many carbons should there be? How many hydrogens should there be? Double check. Okay, you should have drawn them by now. So let's go through some answers. So we have ethene, 2 carbons, a double bond between them, and then 4 hydrogens. Propene, 3 carbons, 1 double bond, and 6 hydrogens around. We've done butene, we've gone through that. So pentene and hexene. Notice that it doesn't matter which end the double bond is on, as long as each carbon has got 4 bonds coming out of it, and that's all they need. Okay? You might get some exam questions like this. Butene, alkene, finish it up. See if you can cover up your work and complete the displayed formula. You get 1 mark. That's 1 minute in an exam. Okay, you should have a final product that looks like that. It does not matter if this hydrogen down the bottom where they've drawn it here is at the top, as long as there's only 1 coming off the carbon. It does not matter if your hydrogen are down to the left and to the right, or if they're up and to the right, or if they're up and down. It doesn't matter, okay, as long as they're just there. So, got a quick table to fill in. Couple of questions. See if you can fill it in. So pause the video, have a think. Okay, we'll go through some answers. Okay, I'm not going to write on the screen, but you should be able to follow along. So the chemical symbols for carbon, C, hydrogen is H. We've been drawing them for 4 lessons now. We should be able to recall what those symbols are. If you are ever unsure, you get a periodic table in your exam, so you can always double check. Okay? Second question, wanting to fill in this table, we'll go row by row. So the first row is expecting us to draw carbon-to-carbon single bonds. And it wants us to use 2 carbon atoms and 6 hydrogen atoms. So we're going to draw, if you've worked it out, ethane. Okay, so 2 carbon atoms with a single bond between the carbons, 6 hydrogens around it. The chemical formula would be C2H6, and the family is an alkane, the general formula being CnH2n plus 2. Now you know that. If you couldn't fill it in before, pause the video, see if you can do the bottom row. If you've done the top row and the bottom row would be 2 carbon atoms with a double bond in between them, 4 hydrogen atoms around it, 2 on each carbon. The chemical formula would be C2H4. It's an alkene family, and its general formula is CnH2n. Have a go at filling in these tables. Alkanes we did a couple of lessons ago. See if you can remember them. If you can't, then go and watch a YouTube video, look at your notes, see if you've made flashcards. You need another way of remembering it, okay? On the right hand side, you've got a table of alkenes. That's this lesson. You should be able to fill that in very easily. And the final question down the bottom, why there is no alkene called methane. If you can't remember, skip back a few minutes, you'll hear me talking about it. Okay? The answers to these are in the video on alkanes and alkenes. They're all displayed in there, so you should have them in your notes. You can go back and check if you want. Okay? So we need to be able to do a chemical test on alkanes and alkenes so we can tell the difference. On the screen, you've got 2 images. On the left, you've got hexane, which is an alkane, and you've got hexene on the right-hand side, which is an alkene. They both smell exactly the same. They actually smell horrible. They are both colourless liquids. We can't tell the difference between them by looking at them or smelling them. We're going to have to use a chemical test. The chemical test is bromine water. Okay, we can add bromine water. Now, in the kind of second unit you would have looked at of GCSE in year 9, talked about group 1 and group 7, okay, periodic table. So bromine is found in group 7. You should know what colour it is. It's an orangey brown colour. It's a liquid. Okay. If you can't remember that, a picture is on the screen so you can see it. Now alkenes, so the one on the right hand side, is more reactive. The reason it's more reactive is because it's got a double bond in there. That double bond basically wants to break up and react. So what alkenes do is they react with bromine water. You end up with this double bond being broken and bromine joining into what was your alkene and is now an alkane because it's fully saturated. It's no longer a hydrocarbon though, because it now contains bromine. But these are the results. Your alkane on the left-hand side will still have the bromine in there. It's just a mixture, it's not reacted. So you'd have bromine and then you'd have your hexane. You'd be able to separate them. You could use distillation to do that. They've both got different boiling points. However, on the right-hand side, your alkene is actually reacted. So there's no more bromine water in your alkene anymore. Your alkene no longer exists. You've actually got an alkane with some bromine attached. Now, trilogy students don't need to know how that happens, but triple do, and I'll explain that in a moment, okay? So the colour has gone from an orangey brown to colourless. Do not say it has gone white, because it hasn't. It doesn't look like milk. Do not say that it is clear, because both of those images are clear. I can see through them, okay? It's colourless. It's got no colour. You might get an exam question like this, talking about the test of an alkene with bromine water. It's saying it turns from orange to, and you just need to pop that colourless in there. Notice on the mark scheme it does say ignore clear. You cannot put clear or white because it is neither. Okay, don't use the word transparent either. So if you're a double student and you have not picked to do triple science or have extra science lessons, you can stop watching the video now. Triple students, there is an extra piece of information you need to know, and we'll go over that now. So triple only, you have an extra lump of information you need to be able to remember, okay? We saw this top part last lesson when we looked at combustion, okay? That's what this top half is about. It's about alkenes reacting with oxygen in a burning or combustion reaction or oxidation reaction. You also need to know, which is the second part, how alkenes react with hydrogen, water, and halogens. That's group 7. You also need to be able to describe the reactions and the conditions of those reactions that we've just talked about, and draw the products of those reactions for the first 4 alkenes. So ethene and the first 4, okay? It has specified the halogens you need to think of chlorine, bromine, and iodine. So we're not talking about fluorine or astatine or tennessine, okay? Other group 7 halogens, just chlorine, bromine, and iodine. So a little reminder about combustion. If you can't remember, pause the video, go back a lesson, re-watch it, re-look at your notes, okay? Alkenes burn with incomplete combustion, with a smoky flame. They produce carbon monoxide, a toxic, odourless, colourless gas, carbon particulates, which is soot, which leads to global dimming, and water. Okay, if you can't remember any of that, that is stuff you need to be able to recall. So go and do some extra learning if you can't remember it. So we're going to have a look at the addition reactions to alkenes. So we know alkenes contain the double bond, which means there's space around those carbons to add extra atoms. It means we'll need to remove that double bond between those 2 carbons so we can add extra atoms, so we can saturate them, okay? It happens in exactly the same way for the addition of hydrogen, the addition of water, and the addition of those 3 halogens, okay? And it doesn't matter how long the carbon chain length is, it's going to be the same for all of them, okay? So I'm going to take you over to the whiteboard for the addition of hydrogen. Okay, so I've brought you over to the whiteboard so that we can go through how the addition of different atoms, and I'm going to show you hydrogen drawn out, and this follows for water. It also follows for your halogen, so mainly looking at fluorine, chlorine, iodine, and bromine being added, but other halogens further down the group like astatine and tennessine can be added as well. So I've brought you over to the whiteboard so that I can draw it out. I am drawing on a tablet on a laptop, which is very different to my whiteboard in my room. However, I'm going to have a go. My handwriting's not perfect at the best of times, but I'm going to try my best. So we're going to draw the simplest version of an alkene. So that's just the shortest carbon chain length. So I'm going to draw ethene. So we're going to pop two carbons next to each other. We're going to join them up with a double bond. That's what makes it an alkene, okay? This carbon on the left-hand side has got two bonds coming out of it, so we're going to have to draw two more because we know each carbon wants four bonds coming out of it. So I'm going to draw one up here with a hydrogen. That didn't work. And I'm going to draw one down here with another hydrogen. Okay, same on the other side because we've got 1, 2 here, so we need 3, 4 bonds coming out. Okay, just pop some hydrogens on those bonds. So we're going to add some hydrogen. So we're going to pop a plus symbol in our reaction with ethene. Okay, and we're going to add some hydrogen. Now, hydrogen doesn't just hang around on its own as H. It's always found as a diatomic molecule. So that means it's a molecule with two of the same atom. So I'm going to put a little 2 down here, which is why it's H2. There's loads of other diatomic molecules you come across, like O2, and all of the halogens as well. So those in group 7. So I'm going to put an arrow in our reaction here. Just going to draw it a little bit longer than I normally draw arrows in reactions. And that's because we're going to pop some conditions over the top of the arrow. So these are conditions, physical conditions, that are used to help the reaction and are needed for the reaction to happen. Okay, so the first one is going to be a catalyst. Okay, so in this reaction, we know a catalyst will lower the activation energy, which means that less energy will need to be spent or put in as electricity into the reaction to heat it up. Okay. We know that catalysts speed up the rate of reaction without being used up, and they are specific for certain reactions. So this reaction of hydrogenation, which is adding hydrogen, it needs to be a nickel catalyst, okay? That's something you do have to remember. You have to remember the conditions for each of these additions, and it's different for each one, okay? We also need a little bit of heat, okay? We know that temperature increases the rate of reaction. We also know that it makes particles move a little bit faster, and they bump into each other, collide quicker, okay? So that's 150 degrees C. It looks a little bit like an S, but it's 150. So it needs to be pretty warm. This hydrogenation will turn our alkene, which is on the left-hand side over here, into an alkane. So we're going to saturate our alkene and turn it into an alkane. So our product that we're going to have, our one singular product, is going to be ethane with an A-N-E. Okay, we know that alkanes have a single bond between the carbons. Okay, so we're going to draw our 2 carbons on, and basically what happens with an addition reaction to an alkene is this double bond in the alkene is broken. It opens up, okay, which means that there's only one singular bond between these 2 carbons. Each carbon wants 4 bonds, still, just as it did over here. This carbon's now only got 1 bond coming out of it, so we're going to have to draw 3 additional bonds, so then it's got 4 bonds coming out of it. Okay, we're going to add a hydrogen onto each of these because that is what is added. Let's say the top and the bottom hydrogen were originally bonded to our carbon, and this hydrogen is our new one, okay? Our one that comes from our pure hydrogen that's added. It's going to be exactly the same over here, so we're going to add some single bonds coming out of the carbon and add some hydrogens on there. Oh God, handwriting is terrible. And that is our product of hydrogenation of ethene. Now, if we changed our reactant, our starting material, from ethene to a different alkene, let's say the next one up, okay, so if we've got 3 carbons, okay, we're going to have to do a little bit of modification to our reaction, okay. So our alkene with 3 carbons in it, so let's draw 3 carbons, 1, 2, 3, slightly bigger, slightly longer. We know that there has got to be a double bond, and our double bond has to be between 2 carbons, and we know it has to be on the end. You only ever deal with what's called a tertiary alkene, which is where your double bond is at the end of the chain length. So you'll never see, let's say you had 4 or 5 carbons, you'll never see something where the double bond is in between any of these in the middle carbons. It'll always be on the end, so either here or here, okay? You do not have to know that they exist, but they do, okay? So we'll go back to our carbon chain length with 3 carbons, and we know this double bond is there. You'll never see anything with 2 lots of double bonds. They exist as well, but you won't see them. So let me just draw this carbon's hydrogen on there. We know it's got 1, 2, 3 bonds coming out of it already, so let's just draw a 4th on. We know this carbon has got 1 bond coming out of it, so we need to add on 3. And this carbon over here, we've got 2 coming out of it, and we'll just add on 2 little hydrogens over there. Okay, so because we've got 3 carbons in a chain length, that means we've got propene. I don't know if I'll be able to fit the word down here. Let's try it. Magic. Okay, we're going to add some hydrogen, exactly the same as before, H2. Okay, I'm going to pop our arrow. Our arrow is going to have exactly the same conditions. Okay, so a nickel catalyst and 150, so better 5 degrees C there. Okay, we're going to have a product that is an alkane. We're going to have propane. Okay, so we are going to draw our 3 carbons in a line, single bonds between each of them, and as you can see over here, this carbon's got 2 hydrogens, and we know it can have 3, so we're going to add 1 of these hydrogens onto this carbon, and this one's only got 1, whereas in the middle it can normally have 2, so we're going to add the other hydrogen onto this atom. We don't want any of our carbons having more than 4 bonds, because that's not possible. Okay, so we're going to add our extra hydrogen on there, and we're going to add an extra hydrogen on our carbon in the middle, so it's got 4 bonds coming out of it, and we'll have our original 3 that were on this side. Okay, now you're expected to know that reaction for the first 4 alkenes, so ethene, propene, butene, and pentene. Okay, it is exactly the same reaction for all of those. We just have an extra bit tacked on the end of our carbon chain length. Okay, so our hydrogens are always added to the carbons around the double bond, and that is it. Okay, so that is hydrogenation, or adding hydrogen to our alkene. So hopefully that has helped you see how it happens. Okay, another example, we have an alkene with 4 carbons there. It's a little bit blurry, you can't quite see the double bond there. Can you remember the name of that alkene? It's butene. Okay, we've added some hydrogen and we've got an alkane, which is butane. You need to be able to do it with the carbon chain length of 5 carbons. So pause the video, draw it out, see if you can name all the reactants and products. Okay, so water is going to be added in exactly the same way. Both sides of the double bond in the previous example gained a hydrogen. For water, it's slightly different. So in this example, we have ethene, so 2 carbons, our first alkene, and we have water. Water is going to split up into OH and H. The H is going to be added to one side of the double bond, and the OH is going to be added to the other. Okay, you can see this here. It doesn't matter that the H is at the top, the left or the bottom. Any are fine, and it doesn't matter that the OH, which is the alcohol group, is on the right hand side. It could be at the top or at the bottom. Okay. You are expected, just with the hydrogenation, to know the conditions. So the conditions of adding water, okay, we add water as steam, so we need to get that water to above its boiling point. If you recall, water boils at 100 degrees C, so our temperature needs to be hotter than that, and we're going to leave it around 300 degrees C. That's hot enough to increase the rate of reaction and to push the equilibrium in the way that we want, if you remember from the rates unit. It's going to be at a pressure of 60 atmospheres. So if you're at sea level, the air around you is at 1 atmosphere or 1 atm. This is 60 times that. So we've got a high pressure there. You also need a catalyst of a strong acid. In this case, it's phosphoric acid. You're expected to remember these conditions. They can ask you these conditions. So there's the example of ethene being added and an example of propene being added. Remember, the hydrogen is added to one carbon and the OH or the alcohol group is added to the other carbon either side of the double bond. Now, it doesn't matter in which order you do that. However, the alcohol group is probably going to be on the end. Okay, it means it's a primary alcohol. So you've got your first 2 examples with carbon chain lengths of 2 and 3. Make sure you do it for 4 and 5. So pause the video. Make sure around the arrows you've got your catalysts and your conditions. And then we can move on. They may ask you an exam question. I did have to trawl through lots and lots of exam questions to find one. This doesn't come up a lot, however, you're expected to know it, so it could come up. If you couldn't remember the 2 reactants to make ethanol, your alcohol, it is in the picture there. But notice the alcohol just has the start of whatever your carbon chain length was, because you've not added or taken any carbons away. Okay, answer there of ethene plus water, allowing in any order, so it would be water plus ethene, and you're also allowed steam for water, because that's what it says in the question. The last type of addition reaction you need to know is halogen additions. They have suggested that it is only chlorine, bromine, and iodine that you need to know. It would be exactly the same for the other 2 as well. Okay. So our example of ethene and chlorine to create dichloroethane, you do not need to know the name of the product. Okay, just that the double bond is broken and a chlorine is added either side of the double bond. Okay, like our product here. The conditions of this reaction, you just need to be at room temperature and pressure. Okay, it will happen before your eyes, which is why we have the test for alkenes being bromine. Okay, we know bromine is an orange liquid. We add bromine and you end up with dibromoethane, or our product, and that is colourless. Okay, so that's our test. Another example, we have our second alkene there, propene. Okay, don't worry that it's bent upwards. Okay, it's just another way of drawing it. It doesn't have to be perfect, remember. Addition of bromine, that would work exactly the same way as chlorine that you saw with our ethene example. Okay, you do have to know it for iodine as well. So how would iodine be different? Hopefully you've worked out. Your BRs would just change to capital I's. Okay, be no different. Conditions exactly the same. So make sure you've drawn that for the first 4 alkenes and the products of them. Okay. The types of exam questions you may see, just like we saw earlier, what colour does bromine water turn when you react it with an alkene? We know it's got to be colourless. And another example is some cross-unit links with the energy level topic or energy changes topic about exo and endothermic reactions. The exam question is there, just asking you to label the activation energy, some axes drawn underneath, and the 3 mark scheme are there as well, okay? But as they don't really relate to our reaction, we're not really going to talk about them, okay? That's everything. Make sure you've drawn out your extra structures that you need and may even try naming them, okay?